It happens in the middle of something that matters. Your hands go cold, your throat tightens, your mind, the same mind that rehearsed this 100 times, goes suddenly, completely blank. You were ready. You had prepared for this. And in the one moment when everything you had trained for was supposed to activate, your own brain pulled the floor out from under you. But here is what nobody tells you. That wasn't a failure. That was your brain doing exactly what it was designed to do. The problem is that it was designed for a world that no longer exists. For most of human history, the moments that mattered looked nothing like the ones you face today. They were not presentations. They were not exams. They were not conversations where a single wrong word might cost you everything. The moments that mattered were immediate, physical, life or death within seconds. A predator at the edge of the tall grass, a rival from another group, a wrong step near a cliff edge in the dark. Your brain evolved to handle those moments, and it got very, very good at handling them. The problem is that your modern life keeps sending false alarms through a system that cannot tell the difference between a tiger and a performance review. In 1915, a Harvard physiologist named Walter Cannon was studying how cats and dogs responded to threat. He watched the body transform in real time, heart rate climbing fast, muscles tensing and flooding with blood, the digestive system shutting down completely, pupils dilating to take in more light. He called it fight or flight.
The system was elegant, fast, brutally efficient. But Cannon noticed something else too. Something that didn't receive nearly as much attention. When the stress response activated, it didn't just redirect blood toward the muscles. It also pulled resources away from something else, something you depend on every single day without fully recognizing it. It pulled resources away from your ability to think clearly. Your prefrontal cortex sits just behind your forehead. It is the most recently evolved part of your brain, the part that plans and anticipates, the part that holds information in mind while you work with it, that lets you weigh consequences before acting, that gives you the ability to choose a considered response instead of just reacting to whatever is in front of you. It is, in every meaningful sense, the part of you that makes you human. And under stress, it is the first thing your brain shuts down. Amy Arnsten, a neuroscientist at Yale University, has spent decades studying exactly what happens to the prefrontal cortex when the stress cascade activates. Her research shows that even mild, uncontrollable stress can impair its function significantly. Not damage it permanently, not destroy it, impair it, in real time, while you are standing there trying to think. The neurons in your prefrontal cortex lose the ability to communicate with each other as efficiently. The chemical signals that help them fire in organized, coordinated patterns get disrupted by a flood of stress hormones. And the region that was, just a moment before, orchestrating your thoughts and your words, quietly goes offline. This isn't a malfunction. This is a feature. In an ancient environment, when the threat was physical and immediate, you did not need to think. You needed to move. You needed to react without deliberation, without considering options, without running through the consequences of each possible action. Fast, automatic behavior kept you alive. Deliberate, effortful reasoning would have gotten you eaten. So your brain learned to switch off the slow machinery and hand control over to something much older, something faster, something that doesn't think, something that just acts. Here is where it gets strange. The same system that protected your ancestors from predators is now firing when your boss sends you a terse 3-word email, when you're about to give a talk in front of people who matter, when someone you love looks at you with an expression you can't quite read and says quietly, "We need to talk." Your brain cannot tell the difference. To the threat detection circuitry deep in your brain, the saber-toothed cat and the critical performance review produce the same chemical signal, the same cascade, the same rapid shutdown of the systems you actually need in that moment. This is not a metaphor. This is biochemistry. When your amygdala detects something it classifies as threatening, it triggers the release of cortisol and adrenaline within seconds. Those hormones flood your bloodstream and reach your brain almost immediately. Your heart rate accelerates. Your breathing shallows and quickens. Blood moves toward your large muscle groups. And your prefrontal cortex, the part of your brain doing the actual thinking and planning and remembering, begins to dim. This is why the most intelligent person in the room can go completely blank in front of an audience. This is why elite athletes miss the easiest shots of their careers at the exact moment the game is on the line. This is why you walk into the most important conversation of your life and forget every single word you rehearsed. In 1908, two researchers named Robert Yerkes and John Dodson were studying how rats performed tasks under varying intensities of stimulation. They expected that more stimulation would produce better performance. That is not what they found. A moderate amount of stimulation improved performance. The rats became more alert, more focused, more motivated to complete the task quickly.
But when your stimulation increased past a certain point, performance collapsed. The rats became erratic, confused, unable to complete tasks they had already learned to perform perfectly. The curve they plotted has been replicated across a century of research. Performance on one axis, arousal on the other. It rises toward a peak, then drops sharply on the other side. It applies to you. A small amount of stress sharpens you. It is the reason you perform better with a real deadline than without one. It is the reason a certain level of pressure actually helps. But past a certain threshold, that same activation works against you. And the moments you care about the most tend to push you past that threshold the fastest. There is a name for what happens to skilled performers when they cross that line. Researchers call it choking under pressure. Sayan Belok, a cognitive scientist at the University of Chicago, has spent years studying the exact mechanism. Her findings reveal something that seems backward at first. Choking is not caused by thinking too little. It is caused by thinking too much. When you have practiced something until it becomes automatic, your procedural memory handles it. The body knows what to do. The skill runs without requiring your conscious mind to intervene. But under pressure, your self-monitoring increases dramatically. You begin watching yourself, tracking yourself, narrating the process in real time while it is happening. And the act of conscious observation disrupts the very thing it is trying to supervise.
A pianist who suddenly becomes aware of which finger comes next. A basketball player who feels the mechanics of their own wrist mid-shot. A speaker who hears themselves talking and loses the sentence they were in. The brain turns observer, and the observer, with its anxious, self-checking attention, ruins the performance it is trying to ensure. This is not weakness. This is a well-meaning system misfiring inside an environment it was never built for. Go back far enough and the picture becomes even clearer. Your ancestors lived in small bands, 30, maybe 50 people, moving together across landscapes that were actively hostile to human survival. In that world, public failure had enormous consequences. To be watched by your group and found inadequate was to risk losing your place within it. And losing your place in the group, in the ancient environment, was often equivalent to a death sentence. You could not survive alone. You needed the others. So social threat and physical threat were, for most of human history, nearly identical in their consequences. Rejection and predation both led toward the same outcome. And your brain, which is above all a survival organ, treats things with similar consequences as similar threats. Standing in front of a room full of people watching you closely triggers the same threat response as standing at the edge of territory occupied by a rival group.